Hi, I'm David with Portrait Displays, and in this video, we're going to go over a quick tutorial using the Lumagen Radiance Pro with Calman Studio. Let's get started. I'm going to come down to my computer running Calman and double-click on Calman Business. With Calman launched, I'm going to dismiss my start session. I'm going to come up here to the Calman menu, come down to Open Workflow Template, select Calibration, and select 3D LUT. With our 3D LUT calibration workflow loaded in Calman, let's get started. The Lumagen Radiance Pro acts as a preprocessor for the display it's connected to. Typically, you're going to want the display in a wide color gamut and in a baseline state. The Samsung display here has already been calibrated, so we already have it in such a state that it's ready to go on its own, but I want to get it ready for the Radiance Pro. So I'm going to take my Samsung remote here, and I'm going to click the gear icon. I'm going to come into the settings and select all settings. Now, I'm in the movie mode, which is okay. It's actually a pretty good mode. It's one that was just calibrated. We're going to come down to expert settings, and I'm actually going to bring my brightness up. This brightness is set for about 100 nits, but I'm actually going to bring this up just a little bit brighter for use with the Lumagen. Let's say we bring this up to 40. We're going to back out, and we're going to keep our contrast, our color, that kind of stuff right where it is. I do want to come down the menu and make sure that I'm in a native color gamut. So let's come over to color space settings and let's select native. So we're putting the display in the widest color gamut it can do. We want to do that so Calman can profile the largest color space it can do. Calman can then create lookup tables or pre-corrections for the Lumagen to pre-process and create whatever color space we want. We're going to be limited by what the display can do. So if the display only does BT709, we're never going to be able to get anything larger than BT709. If the display does P3, we can actually get P3 and 709, and the Lumagen can handle all of that processing all on its own once we have it set up. With the color space settings now in native, let's take a look and see if there's anything else we want to adjust. I'll come down here, peak brightness in medium, that's okay. Once again, we're not doing this for a critical environment, we're really doing this as a quick tutorial to show you how Calman works with the Lumagen and optimizes a display. Let me come back up the menu. You'll notice gamma's at BT 1886. I know this was just calibrated 1886, so I'll actually leave it at 1886 for the purpose of this demo. If it displays native EOTF or gamma responses, say 2.2, you may want to leave it at 2.2 and let the Lumagen do the processing from something, say 2.2 to 2.4. You also might want to reduce the amount of pre-processing that the Lumagen is doing and let the display do the processing. This all comes down to how image processing pipelines work and bit depths work. You want to optimize the image processing pipeline for the best results. Sometimes when you adjust one display too much, you'll end up with, say, banding or contouring in your image. That's when you look at a gray ramp and you start to see striations through the gray ramp. We want to minimize that when we're using a preprocessor. So I encourage you to experiment with this and your own system, as there's really no one solution fits all, but there's always a best solution for the situation at hand. Let's back out of the menu. And for those of you at home, this is a Samsung S95C Quantum Dot OLED. At this point, I'm going to come over to my Lumagen and I'm going to pick up my Lumagen remote. I'm going to press Menu. And just for the sake of this demo, I'm going to come down to Save, and I'm going to go down to Factory Reset. And I'm just going to press OK, all settings, OK, confirm, OK. We're now reset on the Lumagen to a factory state, as if I got it out of the box. OK, so my settings have changed since my last save. I'm going to hit Exit. I'm going to come up to my output. And one of the things I'm going to do is I'm just going to set up the output for what I'm going to work in today. I'm going to press OK on the output. I'm going to come over to Output Setup. And you'll notice I have a 2D mode and a 3D mode. The Lumagen has a very extensive menu system, and you can really configure it in many, many ways, just like many preprocessors do. So right now it's saying that I'm on Input 1, Memory A. I'm inputting 1080p 24, and that's converting to a mode called Custom 0 or Auto 4. And if I'm in BT 601 or 709, I'm using CMS 0. CMS 0 is where our 3D LUT might go, right? So we can put it in CMS 0, 1, 2, 3, as many memories as the Lumagen has, we can save the those 3D LUTs. So if 601 or 709 is coming into the Lumagen, it's going to use the LUT or the correction table that's in CMS 0. Now, if I'm sending HDR or BT 2020 content, it's actually going to use CMS 1. What this is going to let me do is create different corrections if I'm doing HDR content or SDR content. So I can actually have a single input with a single memory going to different LUTs based on the content coming in. Much like a TV switches modes, when it has SDR content coming in, it might go into, say, movie mode. And when it has HDR coming in, it might go into movie HDR. Well, in this situation, the TV doesn't actually have to change the mode. The Lumagen is what changes the mode. The TV stays in the exact same mode no matter what's coming in. Next, we have style. This is a setting in the Lumagen, which we can take a quick look at here in a minute, that allows you to set the output of the device. You might want to output YCBCR. You might want to output RGB. You might want full range or narrow range. This is where you would set that. You can set that up for different instances, and you can tie that to different situations. So you can really, really customize this. And lastly, we have the outputs. We have 4 outputs, and we can do audio, both, B for both audio and video, or we can just do video. Right now, the Lumagen is set up to do audio on output 1, audio and video on output 2, audio on output 3, and both on output 4. It really comes down to the situation and how you're connecting it. The reason it has these outputs is you might actually want to take a video output to, say, a projector that doesn't have any speakers, and another output to an audio device such as a receiver. So you can really, really customize your situation with some of these preprocessors. Okay, the menu is timed out. Let's press menu again. Go to output, output setup, and let's just get this set up. So I'm going to say for all inputs, I'm going to press number 4. Say all inputs and all memories with all signals coming in are going to go to, I'm going to say 3840 by 2160, which is 2160p, 3840 by 2160. I'm just doing this for the demo. You can, of course, set up however you'd like. I'm going to use CMS 0 for SDR content, CMS 1 for HDR. I'll do style 0, and I don't even want to change this. So since I don't want to change this, what I'm going to do is I'm just going to hit enter. And then I'm going to exit. And now the Lumagen is going to store those settings and reconfigure itself. It's now reconfigured itself, and it's ready to go. Now as we come down here, I've done a factory reset, so I know there's nothing loaded in the Lumagen. But as I come down this menu where we have output setup, we have those custom modes that you saw, we have our CMSs. So we actually have 7 CMSs here. You can actually label these if you'd like. You can come over here, select CMS 0, and you can label these. What I like to do is I like to label these for my clients for something like SDR or HDR. So we can come over here, and let's just do that real quick. I just go through it, and I can go SDR. And let's say I have more than one. I could say SDR 0, SDR 1. I'm going to put SDR 0 because I'm going to put in CMS 0. All right. And there's also a bunch of settings here that you can go through manually. You can go through the color gamut. You can adjust it by matrix. You can set defaults, color space, grayscale, gamma tracking. We're going to do all of this with Calman. We're going to set up a 1D LUT and a 3D LUT, and we're going to put all of that in there automatically with Calman while we go through this process. So let's exit out of here. And then I mentioned those styles to you a few minutes ago. If you click on styles, so we're going to arrow down, we're going to go to styles. We have style 0, and you can see we can set this to an output such as YCBCR 422 at 18 gigahertz. We can change this auto 9. We can set this to RGB output if we need to. And sometimes that's actually beneficial. So sometimes you might be converting the color space coming in. So you might have something coming in at 709, but you're outputting it at 2020. And if you're doing that, you might get a matrix mismatch. So sometimes you say, well, I don't want to have a matrix mismatch. I'm going to force it to RGB. So sometimes this comes in extremely handy in getting your color accuracy through the entire display pipe. I'll leave this in auto for now, and let's exit out of the Lumagen menu. So there's a lot of things in here. There's a great manual. Lumagen has great support. I'm going to let you take it from there, but I'm going to exit out of the menu, and let's come back over to Calman. So I've already got my portrait display C6HDR5000 connected. I'm going to click on the meter panel here, and I'm now going to go to meter mode, and I'm going to pick the best profile on my C6HDR5000 for this display. Now I mentioned to you, it is a 2023 S95C Quantum Dot OLED from Samsung. So let's go and see if we can find that here. Quantum Dot OLED 2023. Let's select that. And now we've got our meter profile set up for the display. I'm going to leave everything else alone here, but I do need to connect to a source. Now I have 2 options with the Lumagen. One, I have an internal pattern source inside the Lumagen itself, and I also have our portrait display's G1 connected to the HDMI input. For the purpose of calibration, we actually recommend using the internal pattern source on the Lumagen video processor. Let's go up to source, press find source. We'll select the manufacturer, come down to Lumagen, Select the model as the Radiance Pro connected over USB. Choose your COM port and press Connect. Okay, we're now connected to the Lumagen Radiance Pro, as you can see here in the top right, and I'm actually going to start to set it up. I'm going to change my window size to a window at 10% for the purpose of this demo. I'm going to leave my pattern delay at about a 1. And the reason I'm going to do that is I want to take into account the time it takes to render the pattern on the processor and do its processing, as well as getting to the display. You can try faster delay times, but I find about 0.71, 1.5 is usually ideal for the Lumagen. And it will come down to if you're going through any preprocessor, bail-ins, extenders, etc. So sometimes you do have to play with this when working in these situations with larger video systems that have longer runs and have processors and bail-ins and things like that. Okay, I'm going to leave this now. We have input color at 709, we've got the dynamic range at SDR. So let's come back down here and I'm going to select 3D LUT only. But there's one more step I missed. I've connected to my meter, I've connected to my pattern source, I now need to connect to the Lumagen as a display. So since I selected 3D LUT only, you'll see this here at step 3, I'll press Find Display. We're going to come over to the manufacturer, we're going to select Lumagen once again, and we'll now select the Radiance Pro USB, and we'll press Connect. Okay, we're now connected to the Lumagen's Radiance Pro as a 3D LUT in the displays, we have it as a generator, and we have our meter. Let's press Next, and now we want to set our targets. Now remember, I told you, the Samsung display is actually set up to a B1018A6, so let's get a little crazy here, and let's set this up to a power function at 2.6. Now this isn't something you would do with BT709, but once again, we're going through a quick tutorial here on how you can use the Lumagen to better your video system. So we've got D65, BT709, and a power 2.6. Now let's press Next, and let's take that pre-calibration capture. So I'm going to come down to the bottom and hit Read Series. Calman's going to put up a patch, take a reading, and plot the data for us. Okay, you can see the pre-calibration capture finished. You can see our EOTF is no longer hitting that target line and our color gamut is way out compared to BT709. You know what though? The grayscale is pretty good on this. And like I said, we have just calibrated this. So you know what I'd like to do? I want to go even further. I want to mess this up even further for you. So I'm going to select the settings, go into all settings. I'm going to come over to picture and I'm going to see if I can reset this here real quick. Let's go to white balance. Let's go to 2 point. And let's reset that. Let's just reset the whole thing. We're going to reset this. We're going to reset this 20 point. Let's reset the whole thing. All right. So now, even though it was calibrated, let's now take a measurement and see how we have it. I'm going to open up a history 2. And let's take a quick read series. We want to make sure this is really messed up. I actually want to show you how much the Lumagen can actually improve this display when it isn't in the ideal state. All right, our pre-calibration capture is completed once again. Now you'll see we actually do have an EOTF that's not quite as good because we had our grayscale fixing this a little bit. We also have a white point that's now shifted, and we have a native color gamut way off of 709. So now we actually have quite a bit of improvement that we need to make to get this display back into BT709 at a 2.6 gamma. So let's go next. And we're now at the 1D LUT portion of the project. So typically, you're going to create a 1D LUT, and then you're going to create your 3D LUT. So I'm going to come down here to the Auto Cal button in the bottom right. I'm going to press Auto Cal. I'm going to come over here. I have 11 points, 12 points, or 21 points. Now, we're just doing a demo, so I'm just going to do an 11 points so we don't have to sit here all day. But I do encourage you to use 21 points. I actually find that the 21 points works well in the work I've done with the Lumagen when using Calman. While this measures, let's take a moment and go into some of those points. I'm going to grab my trusty whiteboard, and I hope you'll forgive me with my chicken scratch, but let's grab the whiteboard and let's take a look at what's happening when we do these points. So let's say we have an X and Y axis, and we have our EOTF curve similar to what you see in Calman right now. So we have our target line. Now what's happening here is Calman's looking at this EOTF, and it's actually taking a certain amount of points. So it's not really doing a true 1D LUT when it comes to Calman performing the calculation. Instead, it's adjusting points, and the Lumagen is doing the calculation. So let's say we have a point here, we have a point here, we have a point here, 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 here. Okay, so with these limited amount of points, Calman's going to go in, it's going to measure this, and it's going to adjust this until it gets to the target line. So let's say we're currently measuring here. Calman's going to adjust it until this equals that. Then it's going to go to the next point, and it's going to adjust this until this equals that. And it's going to go through all the points. Now what's happening in between these points is the Lumagen is taking the correction and it's interpolating the points in between through its 1D lookup table. So the more points we measure here, the more finesse we have on the curve. So let's say we're out here and we're out here. So if we're out here and we're out here, but our first point is here, we're going to end up with a response something like that maybe, where we don't know what's going on down here that's wrong, but we fixed here. So having a true 1D LUT sometimes helps us a lot better because we can choose what points we measure and what points we need to correct. Whereas when a manufacturer gives us specific points, we can only work within the points they give us, and then we have to trust that it gets interpolated well. Now this will all come down to what display you're working on. If the display is fairly linear, this isn't going to be a problem. If a display is not linear or highly not linear, where you do have a response curve that varies quite a bit, you're going to want more points. So I encourage you to use 21 points for most of the time, but you will find sometimes you can do 11 points. On a linear display, that's going to be more than enough. In fact, sometimes you can just do a 2-point, and that's going to come out really well. We'll put our whiteboard back, and let's see how this is doing. Okay, our 1D LUT calibration, or multi-point calibration, has completed. The full calibration completed successfully. It took 7 minutes and 42 seconds, and it took 99 reads. Let's press OK. If we take a quick look at the charts, we're doing about 272 nits, pretty bright. We're doing a EOTF that seems to be tracking that target yellow line, and our RGB balance looks pretty tight. Let's move on and press Next in the bottom right corner. We're now at the 3D LUT calibration portion of the workflow. Let's come down to the bottom right and hit AutoCal. The AutoCal setup window is now up on our screen. So we have a couple options here. We have a start delay in minutes. Well, if I was going to leave the room, I wanted to turn off the lights and run a long LUT and make sure everything's perfect before I leave, I can put a delay. Maybe I need a minute. I can set this to 1 minute. I can hit start, turn off my lights, get my belongings, grab my phone, get out of the room. It's going to start, and it won't get any interference from me leaving the room. I also have this option, set 3D LUT grayscale to unity. Sometimes when you're adjusting a display, the heating, cooling, and even meter repeatability can step on the 1D LUT or the multi-point you just calibrated. For example, let's say you had 50% gray perfectly calibrated to 3127, 329, but then your meter measures 314, 331, a difference of 0.002, well within the tolerance of most meters. Well, Calman might want to try and correct for that and add a little interference to the results. So if I have a good 1D LUT, a good response curve coming from it, and a good grayscale coming from it, I typically will set 3D LUT grayscale to unity so that my 3D LUT doesn't try to step on the 1D LUT. We're going to leave that checked. And then we have an option for a calibration type. Now we have a bunch of options here. We can do a 21-point cube, 17-point, 13-point. We can do one of our lightning LUTs, and we can also do a matrix LUT. Now, for the purpose of this demo, let's just do a matrix LUT. That's going to measure red, green, blue, and white, and it's going to create that correction. Now, I'm banking on this display having a fairly linear result. If it doesn't have a linear result, a predictable result, we might want to do more points. Of course, the more points you do, the longer the calibration. Let's select matrix LUT, and let's press OK. If in fact you are measuring a display that isn't linear and you find out the matrix LUT doesn't come out well, you can reset just the 3D LUT in the DDC settings and you can start over. Okay, our Aurora color engine has completed the calibration successfully. It looks like it took 5 minutes and 27 seconds and it took 5 reads and then computed the correction. Let's press OK. And then press Next. Now it's important to note that as Calman walks through this process, it's actually loading directly into the Lumagen, right? There's no additional steps. You go through the process, Calman performs the correction, it loads it in. There's no creating a LUT, targeting a LUT, creating the file, loading the file. We take all of those steps out with Calman. So let's take a read series here on the post-calibration capture. Okay, our post-calibration capture is completed, and if we look at our EOTF, we do have a little bit of a dip here on the bottom, but remember we only did an 11-point grayscale, and then we are tracking very, very nicely compared to that pre-calibration. Our grayscale, which we threw out when we did the reset on the Samsung, is now dialed back in, and again, we only did an 11-point, but this came in very nicely, and it looks like our color gamut is tracking to BT709. But this is only really part of what's going on, right? Whenever you build a LUT, you don't really want to look at those edge colors. You also want to look at the inner colors. So it's easy to get those edge colors right when you do something like a matrix LUT. But what's important is, how is the inner part of the gamut mapping? After all, that's where things like flesh tones in most colors live. Most colors aren't fully saturated red. They're not fully saturated green or blue. They're somewhere in between that triangle. So let's come over here and press next. And now we can do an additional validation. I'm going to click on additional validation because I want to know a little bit more and show you a little bit more about what happened here. So right now we're on a color checker. And let's just do this basic color checker by hitting read series. Okay, our color checker is finished, and if we take a look here, we do have some errors. You know, we are mapping very well compared to where we were pre-calibration. We do have that 3D LUT loaded, and we do have some errors here. So it's not perfectly linear. Now again, we didn't get the grayscale EOTF perfectly because we did an 11 point, and we didn't do more than a matrix LUT. But you get the idea with this quick tutorial as to how you can do that and how you can improve your results. We can take one more measurement here. Let's go back down to next, and let's measure those saturation sweeps. I always like to do both of these when I go through this advanced validation process. Okay, so our saturation sweeps have completed, and if we take a look at the chart, we'll notice we do have some errors inside the gamut. If you look inside the gamut here, you'll see we're not doing as well as we are in the outer portion of the gamut. Of course, we measured a matrix LUT. We measured red, green, blue, and white, and then we created a correction table. So we're measuring those edge areas, and then those inner areas aren't linear, so they're not coming out as nice as we'd like. What I would do here if I was going to improve this, I'd actually reset the 3D, reset the 1D, do that 21-point grayscale for that 1D, and then I'd move over to maybe a 5x5 or maybe a 9x9 3D LUT to get a little more granularity here on the CIE chart. You'll notice our delta E's aren't too bad. We've got a max of 3.8 with an average of 1.5. Those delta E's aren't terrible, right? But we do have more of that error near that 20%, and then you see it come down as we get to that 100%. Now there's one more extremely critical thing. I've been bitten by this myself a couple times, and it only takes 1 or 2 times before you'll never get bitten by it again. And that's saving the Lumagen. We've done all this calibration, we've done some configuration, but if we reboot the Lumagen, it's gonna reset it. So let's press menu, and let's come down and press save, save, save. Okay. We've now saved the settings on the Lumagen, so if we do reboot it, we do have it. You can also download a utility from the Lumagen website that allows you to back up the Lumagen, so if you ever swap out your Lumagen, or if someone accidentally erases it, you can restore the memory. I hope you enjoyed this quick tutorial with the Lumagen Radiance Pro in Calman Studio. We'll see you on the next one.